So everyone, our friend Babak couldn't actually make it. He's had knee surgery after a sort of football incident. So I'm stepping in to take his place. I'm Josh Renton.
Yes, please. I would have introduced you, but you seem to have started.
Oh.
This is Josh Renton. This is Dan Milburn.
Oh no, we'll wait.
Milburn and the man formerly known as Babak Khataee, and now Josh.
That's my code name.
That's recovering from surgery on his knee at the moment.
Okay. Welcome to Untitled Nukes. I'm Josh Renton, as I've said. This is my friend Dan Milburn. We both work on the Foundry's flagship product, Nuke. I'm a QA, he's a dev, so I'll try to go through it, but my understanding is a bit limited compared to this, but I'll be pretty famous in the flashing hands. The talk aims to really explain what Nuke is and how we've incorporated Python into it. The reason we've done that for the automation and customization for our customers, while also it allows us to test and develop in Python instead of C++, which for me is quite nice. So we'll start with a brief explanation of what Nuke actually is and where it fits into the industry, some basic functionality, and then expand on Python bindings themselves, how they relate to the underlying C++, how compositing artists use it, and then how we use it internally. And finally, we'll cover a few of the problems we encountered in this process and what we have planned for the future. Thanks for joining us. Firstly, though, we'll show you a bit of our show reel, just so you get a bit of a taste of what Nuke is actually used for in the industry. Sorry, good sound quality here. Sorry. No. So there's a little clip. We thought we wouldn't bore you with the whole thing, but if you'd like to, it is online, so check it out. So first of all, so what actually is Nuke? Well, in buzzwords, Nuke is a non-destructive, node-based, 32-bit float, multi-channel system, scanline image rendering system. Alternatively, it can be said that Nuke's a bit like Photoshop, but for videos. And we use it to make composites. A composite is an image that's made of multiple discrete sources, so that may be footage from different times or locations or CGI as well. But the art of compositing really is convincing an audience, or at least tricking their mind, that everything in the shot was done at one shot with one camera at one location at one time. Although CGI dragons are relatively easy to spot, lots of elements on, and they do trick audiences very well. An example of that is this scene here. So this is an extract from FX's hit TV show The Walking Dead. I want to ask you how much of that shot you actually think was positive.
What's not compositing? Is that easier?
Yeah, that's actually a better way of thinking about it. As you can see, absolutely most of it. If we jump back, you can see that, yeah, so the cliff face, the river, the foliage, and actually the shot itself has been transformed down, so it's completely changed the whole camera angle, really, and created most of the tone and atmosphere of the shot. To give an idea of where Nuke really sits in the production pipeline, here's a relatively simple animation image of an animation pipeline. It should be noted that that there will be some differences for live footage, but in general, this is the layout, and here we are in the bottom left down here. I'll now hand you over to Dan, who will talk a little bit more about how the insights of Nuke really work.
Right, so the core of Nuke is the node graph. It is a node-based system. Everything is done by creating nodes, attaching inputs between them. So you can see the view of what we call the DAG, directly acyclic graph, at the bottom, and a really simple setup with just a read node, which is outputting to the viewer, which is also represented as a node. So then bring in some CG renders, and a merge node, which just does some alpha blending to merge the CG on top. Obviously, a lot of time you'd be doing green screen or something rather than this very simple example. And then a few extra nodes to add grey and make everything purple. So that's just a really simple example. There's also a 3D system which this doesn't touch upon. The idea. So each node has set parameters which control its operation. For example, green needs file path, merge node has various algorithms which you can select, etc. We call these parameters for reasons I have no idea about, they're called knobs. It's a constant source of hilarity.
You can make your own.
So you can see in the video, various knobs. The VUIs are sort of generally constructed automatically based on the knob type. They store all sorts of data, like points and strings up to complex data structures. And the key thing really is that they are animated and also controlled through the Python API if you want to do that. So it's important for our users to customize how they work and automate things. Python is the standard scripting language in all our company's products and across the visual effects industry for providing this functionality. A lot of our APIs are actually in C++, and that's what you do if you wanted to create a new node type to do some sort of image processing operation. Python API is high level and is more about A, manipulating the node graph, creating node state values, and B, user interface customization, which is a big thing. So yeah, and the nodes all very simple, modular. You can do a lot with that. It's also worth bearing in mind that most of our users aren't actually professional programmers. So the APIs are targeted at people who are primarily artists. So that's something to bear in mind. We also can use Nuke in terminal mode, either with an interactive interpreter or executing scripts. You can also embed Nuke as a Python module in standard interpreter, so it can be used as a library for 2D, 3D image processing to embed in other applications. So we have another application called Flix, which is a sort of web-based thing and uses the backends to do transcoding videos. So the bindings, Nuke is primarily written in C++. We embed the C Python interpreter. We're on, and will be forever, the Python 2.7. That's just the industry standard. So the Nuke module is a mixture of all-strect Python code and bindings the C++ layer. So that's a mixture of manually coded bindings, and we also use the Babak tool, which is part of the PyCon project, which is a code generator that takes a fair bit of the tedium of writing bindings out of it. So you just create an XML definition file to tell it where your classes are, and it should do it. Although that is an alternate out of certain problems. So, as I said, our main users are not programmers, they're generally artists. They don't really have to use Python. Nuke is overly usable without any coding, but those who can work more efficiently. They can do things that would be difficult to achieve in other ways. Larger visual effects studios, such as Meta or ION, will have in-house engineers, and they will do all sorts of customization and integrating stuff with their pipelines and so on. So, a straightforward way to use Nuke is simply that you can use expressions to drive animation on values, so videos showing bits of that. So just setting up a sine wave for the animation of this cube, I think. Yeah, so fairly simple thing, but you can see, if you just know a little bit about how to write a simple Python expression, then you can do stuff that would be rather difficult to do in any other way. The node graph is where users spend most of their time working. One of the big issues is that projects get very complicated. So we've got here an example of a fairly large node graph. Just managing that, navigating around it becomes a problem. So, one of the things, this is just demonstrating a simple tool which can be used to align the nodes. So that's the third-party thing, and this is the code for it. So our APIs make it very easy to just set an outer menu, set up shortcuts, and call back your function. And there's the simple thing which just takes a list of nodes and makes sure they all have the same X or Y positions.
So, another example of how users can automate their work in Nuke is through callbacks. Actions throughout the UI, opening scripts, rendering frames, or changing parameters, all trigger events. Being notified of these allows for a lot of flexibility when controlling the application's behavior, and also from a manager's point of view, controlling your artist's work. Nuke provides a lot of callbacks, which can be used for things like connecting to an asset management system on project creation, setting default values on object creation, doing backups before rendering, and enforcing naming conventions. While these aren't terribly sexy, they are vital to having an environment which can support hundreds of users working with the same project at the same time, which is really a key part of our success. Another main thing, as we mentioned, is UI customization. It's a huge thing for artists in Nuke. It does use Qt underneath for the UI, so users can use PySize or PyQt, but UI toolkits aren't really their domain, and they shouldn't really be expected to actually know how to use them. So we've provided a wrapper system such as this Nuke.panel. We use Nuke.menu in the previous example as well, which allows you to access your menus in a Pythonic way and add sub-menus or extra items to these. Another level of abstraction is provided on the knobs themselves, which, as Dan noted is how parameters, a control, and nodes. When these are combined together, you can get some really much more powerful tools. And I'm going to give you an example of this now. So this is an example of a field of view calculator, which can convert between an aperture, focal length, and field of view. It's a non-trivial piece of code, 220 lines long, but all of it is being managed by just the knobs and callbacks. The knobs provide the UI in the same way as default tools will, and the callbacks controlling the UI reaction to input by the user. And here's the code, well, an extract of the code for this. We've left out a few of the minor bits. The main thing really is about this knob change function down here, which as this inherits from a Python panel, it knows that any time the value of a knob is changed, this function should be called, and then you can control what is exactly happening. It can let you define if this knob has this name, then do this, or ignore it if it's this knob. It does allow for a lot of control with a relatively light syntax. We're really lucky in Nuke because we have a wide user base who are more than happy to actually share a lot of their tools. The examples that we took today are from a guy called Frank Reuter, Nuke super guru, who runs this website, Nukepedia. So if you are interested in checking any of this stuff out and want some customizable tools, this is your first point to actually look at. So that's kind of a brief overview of how our customers can use it, but really what's important for us is how we can use it as well. And although it's widely used to pass information around the application between different systems, turn blue, we'd like to really draw your attention to two things, which are automated testing and distributed rendering. Our test harness is pure Python, which is really nice for me, and it's conceptually not dissimilar to the test unit, so the unit test module. But we run it internally. We write it internally, excuse me. We have around 3,000 tests which run each night. That takes about 10 hours. It's quite long. There's some variation across the platform. We also run a subset of 1,000 tests as a continuous test set as part of our continuous integration with Jenkins. Those can be specified. Those are split so that you can target on specific areas like licensing. So if you just want to check your licensing, you'll just check those rather than doing all the rest of it. So it's run by Jenkins, find out slave machines as jobs, and then we can get all the results back via an internal web database tool.
So one thing we added recently, which is kind of notable because it's entirely written in Python, is some very simple support for distributing the rendering. So one of the big problems is, you get those large scripts or certain those which are very computationally expensive, and rendering a single frame can take hours. While the third-party tools for doing the files or rendering in the cloud, etc., we wanted to add something to the product directly, just to make this a bit better, which is what we call the frame server. So by default, that will just run multiple new processes on your local machine. This will make things better, take more advantage of multiple things because multi-threading is not that great. So it's entirely written in Python. We use the 0MQ history library for the networking stuff, with the Isaac and Q bindings. And that just runs in the background, starts up Nuke processes, sends frames and surrender, monitors and manages all of that stuff. And if users want to, they can just configure it to run on multiple machines across their local networks to make best use of the workstations they have sitting around. So problems, I think these are problems mostly that anyone trying to embed Python runs into. So the GIL has caused us some difficulties, mostly when people forget to do allow threads in the bindings code. And the other thing which can cause difficulties is just actually managing object lifetimes between the Python and C++ side of things. So obviously in Python it's all reference counted. As soon as you stop referencing the object in the Python interpreter, it will get deleted. And so if you're using PySide to build UIs and you forget to hold on to a reference, the widget you just created, it'll just disappear. So in terms of Nukes bindings, we try to make sure that the Python objects do actually persist for as long as they do in the C++ model. Future. So in terms of Nuke generally, I think one of the big things that's happening at the moment is obviously lots of interest in VR. And Nuke can help with this. So people are sort of doing projects to use the compositing in Nuke to project like panoramic 360-degree panoramic images onto a sphere and stitch it all together in Nuke to try and put together something that you can then use in a VR situation. So that's an interesting direction. Although I'm not convinced that's going to be as big as everyone else thinks it is. So in terms of Python, the APIs, we're always looking to improve them. There's always new features being added that we need to support. Importing it as a Python module has a few problems, as I mentioned. We'd like to clean that up, make it cleaner, get rid of the dependencies on Qt and other stuff, which can make it a bit trickier for people to just import it into their applications. And another thing is we've discussed providing Python APIs for doing stuff that you can currently only do in C++, so creating image operators, doing your processing. Obviously there are performance implications there, but Python is very good for prototyping. So that's another area we'd like to pursue. And that's it. Thank you for listening. I'd just like to end by saying that we recently released the Nuke non-commercial version, which is entirely free to download and use for personal use. The commercial version is expensive. It's a niche industry tool, so but you can play around with it for free, and it does most of the functionality is available in the non-commercial version. Most of the stuff that isn't there is because of third-party licensing issues. So that's available on Windows, Mac and Linux, and if you've got any interest, please go and grab it. And if anyone's got any questions, we'll try and answer them.
Got a few minutes for questions.
So is you say that it's 2.7 is Python 2.7 is the version you're currently referencing.
Yeah.
Is that primarily because of Qt and PySide, things like that?
It's partly that, and partly there's an initiative called the VFX platform, which is set of standards for all the companies working in the industry to standardise on wider versions and stuff like that. So that's all on Python 2.7. And I think, the problem we've got is because our customers are writing their code against our APIs, we can't really change that without a very good reason, or they're just going to shout at us.
You already do a lot anyway.
Yeah, but backwards compatibility in Nuke is a big issue because film production can take years and years and years, and they need to make sure. A lot of the time they will just people still using versions of Nuke from 10 years ago because that's what they know, and they know it's going to produce the same output that it always has. But yeah, we need to make sure that we don't break this.
How do you store the rough node for a project? How's that?
So that's actually persisted in TCL. So you said that I get what we call an AK file, which is just sort of purely readable TCL script, which is, as far as I know, it's been before my time, but that was originally what Nuke was written with, and I think supported that later. But that's quite nice because it's very easy to read. It's really only a problem when you have, if you just got one road feeding into another, then you just need something to read it. But if there's lots of multiple reports of management and stuff, it's a bit of a nightmare.
Okay, do you want to do it there?
I can just add.
Yeah, sure.
Python was, I believe, version 5, which is 2005. And I guess it was our first major release when the product was taken in by the foundry. It was part of the first major release, so it was one of the first things we did was to upgrade the QT from the name of the other
FLTK.
FLTK, yeah. It was, and then we upgraded both at the same time.
Thank you very much.